Oh, hello, Salma. Yeah, customer segmentation and risk-based segmentation, they're two completely different things. And I found a presentation that well, I was the responsible for something when I was working in a bank called macro codes. There was a set of many codes done in SAS language, and one of them was written by Paul Day, and it was the one for segmentation that I'm gonna explain really quickly what it does. And you actually gave me a very good idea, this project here, because I haven't found anything written in Python for doing risk-based segmentation. There are a lot of things to do with customer segmentation, and in customer segmentation, the idea is to maximize the proximity of different people. So putting together in different clusters people that are similar behavior, similar characteristics, similar profiles, or something like that, so that you could use potentially for marketing campaigns and so on and so forth. In risk, it's a different story altogether. So what we should do? Well, basically, this is just a thing about the methodology of these codes. Basically, takes about 3 hours to run. It wasn't optimized. It was in SAS, not in Python. In Python, I'm sure it would be quicker, but we don't have access to it in any case. So you have to do it manually. But I will explain what you need to do, what's necessary, and not the whole code. You don't need to develop an automated code, but it will be something that I'll keep in mind, because in the future maybe I give it as a project for IE. It's very interesting for my risk and fraud analytics course actually. But the basic idea is imagine you have the whole population. You're going to call it no segmentation, and then the idea is divided. Let's suppose you have age below 25 and above 25. Existing relationship, yes or no. That means no relationship, no, it's a new customer, and yes, it's a it has relationship already, so it's a current customer. So there are two types of segmentations we do. The first segmentation is, yeah, based on the data you have. So let's suppose for some kind of people, you have a lot of missings and on the data, and for some you realize that you have a complete set of data information, and maybe it's because they are different. One is an existing customer, or one is a new customer. You don't have behavior or use of the credit card and so on and so forth, and for another one you do. So it's a logical segmentation that we use in risk. It's called business segmentation, or sometimes it's risk segmentation that we use. So based on the data. So first thing first, you have to explain that based on the data, you have found that you have a cluster of these guys having a lot of information, and these guys have little information. So that means that they probably they are different group of people. So it's based on information. I can give you a lot of examples, like foreigners with the local people in the country, because local people, you have more history than foreigners that just came into the country. What else? New customers compared to current customers. Current customers, you have behavior information. Sometimes you have in credit cards or in bank accounts, you may have high users versus low users. So with the high users, they have a lot of transactions. With the low users, you have very little transactions. So maybe that's a good segmentation. But that's not based on the data availability. So the first segmentation was to do with data availability. You either have or no, or you don't have the data. So there's nothing you can analyze. It's just a decision. I'm going to segment because for some I can use certain variables and for some I cannot. For example, for companies and for individuals, it makes all sense to have two different models, because for companies you're going to have a set of variables, and for individuals you're going to have a different set of variables, gender, where they work and so on and so forth. And in companies you have what they build, what they sell, what type of company it is, but you don't have what type of company for people. So where they work, that's for individuals. So different data for different people. So then you segment them. Right. And what else can you do? So that's the second step. So you should start with the first step. And the second step is, now that you decided, can I that I have the same variables for these guys, how do I segment them? You shouldn't ever do a cluster or anything like that, because that's for segmentation for marketing, because it's going to find people that are correlated, that are similar. And what we need is a different thing. Let's suppose here age to above 25 and below 25. And this one, I don't know if it's a good segmentation. How do we find out? And how do we find out? We do this way. What we're gonna do is we're gonna develop a model with the segmentation and without no segmentation and with the segmentation. So age here as the segmentation. And then I'm gonna focus on what we see here now that in this slide. That is, you have to compare either the Gini or the KS. I recommend you use Gini because you have the code really easily. So you try to use Gini because that's a standard especially in Europe. If it's a European bank or anything here in Europe, the guys use more Gini. If it's something on the US or Americas, you use KS instead. Don't ever use accuracy. They'll think you don't understand what you're doing. Therefore, what we're going to analyze is the Gini of the segment using the segmented model versus the Gini on the segment using the non-segmented model. Meaning that, yeah, we're going to do above 25, and then we do the development Gini. That's the train. This is train Gini, and this is test Gini, and this is test Gini. But here's the training Gini using the model the segmented model. So what's a segmented model? You segment below 25 and above 25. And because you have below and above, you train two models, one for below 25 and one for above 25. Then you evaluate the two models, the below 25, the above 25 with the above 25 model, and the below 25 with the above 25 model. And then you get the non-segmented model. You train a model without breaking the population. You put all together and train one single model. And that single model, well, that has a Gini on the whole population, but I want to compare if that Gini is a good Gini on the segment. So I get the above 25 people, and I get that model that I trained in the whole thing. And I can see here that it got 60%, nearly the same, but even better. And below 44, below 25, it was really bad. Really bad. So this is literally similar, but this is a very big drop here. Therefore, I would say that this is a good segmentation. Not because of those ones, because they're similar, but because of this guy here. Because of this guy here. And this is how the Gini would work in the whole population, taking the prediction of the two models, meaning that applying the above 25 people got the prediction from the above 25 model. Below 25 people got the below 25 model. And then you put all the predictions in a column and calculate the Gini. That's the all here. And as a all, you see that a separate model, two separate models beat the overall model, the model that was developed on the whole thing. Obviously, the Gini on test, that normally we normally use as well, it has to agree both, in this case, the training and the test. And you can see here that in the test, the things became even better in this case because the segmented model was better always in the above 25, below 25, and overall. So what you need to do is exactly what's in this PowerPoint here. You find a possible segmentation. The thing is, our our tool would automatically get many variables, train many models, and then propose the segmentations. You don't have that. So you pick some variables that you think make sense. Then you segment that variable up, like above 25 and below 25. And there you need to train 2 models and then test those models on those segments against the overall on those segments, and those models, you do the prediction, combine all the predictions and do an overall, and do it against the overall model, the one without segmentation, the not segmented one. Remember, we in IE, we call this train and this test. This is a UK thing. They normally call it development and holdout, but it's the same as train and test, okay? And don't bother about the other metrics we use here, because you probably don't know what they are, but don't worry about them. Well, this is it. As I said, I'm really looking for to work in the next, maybe the next term, to create this automatically thing, because we have created for like a script that actually breaks down using techniques the population and test it if it's either a good thing automatically. It's not difficult to implement. It's difficult to improve, to do it fast, but it's but it's a good challenge. It's a good challenge. There is nothing in the market that I'm aware of for risk in Python or in R, because segmentations are more on proximity, not on the output of the model, or separating or making sure it's better to segment for the risk-based. The thing is that it's better to do a model for this segment of people and better to do a separate model for those segment of people. And there are 2 important things, if you remember. The first one is data availability. There's nothing to test if there is if there are more variables, more characteristics in one group and less in the other. It's obvious. It's a go ahead, go and do 2 models, because of data availability is a clear cut. But if the data is not a problem, you have all the data for everybody, then it could be that one variable would be an ideal segment or variable to segment on, and this test that I just showed you is how you test it. You do the model and you test in the segments against the overall, and then you find out if it's a good idea to segment or not. So I hope this helps, and get this going, and then try to explain your rationale. I think if you try a couple of segmentations and explain well how this segmentation differs from customer segmentation in marketing, and how you've done your analysis, and luckily you find a variable that you can segment on. Okay, I'm just seeing the variables. So what I would say is, you say, well, we could actually try to segment. I could done my analysis by gender, by sex, but that's a clear bias. So I wouldn't even test it, that type of segmentation. But I tested age using birthday. So I calculated age and tried above 30 and below 30, or like young and old is a good try for segmentation. Profession is also a good thing, but you need to get together professions that make sense, like group them before even segmenting, group related professions before even trying to segment on the different professions. car type actually makes sense because it's an action of the customer. So based on which car that the customer wants, it may be a good idea to segment. So you need to group all the cars together into many groups and then try the segmentation. Well, hope this helped. Good luck with the